Welcome to this highly focused explainer. If you've ever stared at a diagram of the human heart and just felt, well, completely overwhelmed by that crazy maze of chambers, valves, and vessels, listen, you are definitely not alone. It is a notoriously tricky system to memorize. But today, we're going to change that. We're going to tackle a 3-minute heart speed run. By the end of our time here, we're going to cement the entire pathway of cardiac blood flow into your memory, literally for good. We'll break all this complex anatomy down into a super structured, visual format that you can mentally rehearse in under 3 minutes whenever you need it. No fluff, just the absolute essentials designed to make this knowledge actually stick.
So, why do we keep forgetting all this anatomy stuff in the first place? Well, the answer lies in one staggering number: 70%. According to the famous Ebbinghaus forgetting curve, which maps exactly how our brains lose information over time, without active memory hacks, we lose a massive 70% of newly learned information in just 24 hours. And get this, the sharpest decline actually happens in the first 20 minutes. So yeah, reading a textbook over and over just isn't going to cut it. To beat the curve today, we are using intense visualization, powerful mnemonics, and spaced repetition. The mental map we're building is specifically engineered to create strong neurological connections. So I need your absolute full attention right now. Let's build a mental model that totally defies that forgetting curve. Okay, first up, let's establish our golden rule. This is the absolute foundation of heart anatomy. We divide the heart into two distinct sides, color-coded to help your memory. On the right side, represented in blue, we have deoxygenated blood. Think of the letter R here. Right means returning to the lungs. This is the blood that's been all used up by the body and is practically begging for some oxygen. On the flip side, the left side, represented in red, holds the oxygen-rich blood. Think of the letter L. Left means leaving for the body. The whole purpose of the left side is to take that fresh, oxygenated blood and pump it out to your brain, your tissues, your whole shebang. So remember, right returns, left leaves. Go ahead and lock that concept in right now, because every single step we take next builds entirely on this simple binary.
All right, let's put this into action and literally race a red blood cell through the right side of the heart. There are exactly 6 steps here. Step 1, our blue deoxygenated blood enters the heart through the superior and inferior vena cava. Step 2, it dumps into the right atrium, which kind of acts like a holding chamber. Step 3, the atrium contracts, squeezing that blood down through the tricuspid valve. Think of this as a one-way door to stop backflow. Step 4, we drop right into the right ventricle. Step 5, the ventricle contracts super forcefully, shooting the blood up and through the pulmonic valve. And finally, step 6, the blood travels into the pulmonary artery. Now pay super close attention here, because this is a classic exam trick question. The pulmonary artery is the only artery in the body that carries deoxygenated blood. Crazy, right? But it makes sense because pulmol means lungs, and it's taking that blue blood straight to the lungs to grab some oxygen. Bam! That is your right side speed run.
So now that our red blood cell has secured its precious oxygen in the lungs, the journey transitions over to the left side. We've got 6 more steps to complete. Step 1, it returns to the heart via the pulmonary veins. And yep, again, these are the only veins carrying oxygen-rich blood. Step 2, it enters the left atrium. Step 3, it passes down through the mitral valve, which you might also hear called the bicuspid valve. Step 4, we arrive in the left ventricle. Now let's just pause here for a second. The left ventricle is incredibly important. It has this very thick muscular wall known as the myocardium. It has to be immensely strong because its job is to push blood to the entire body. Step 5, this powerful muscle forcefully blasts the blood up through the aortic valve. And step 6, the blood exits through the aorta, the body's largest artery, where about 20% rushes straight up to fuel your brain, and the rest travels down to your liver, kidneys, and throughout the rest of your body. Okay, so you know the path now, but how on earth do you memorize the exact sequence of those 4 critical valves without completely mixing them up under pressure? Well, by using a wonderfully absurd mnemonic, of course. Research actually shows that the more ridiculous a mnemonic is, the better it sticks in your long-term memory. So, to lock in the chronological order, we're going to use the phrase, toilet paper my assets. I know, but it works. It gives you the exact chronological order of the valves as blood flows through. Toilet for tricuspid, paper for pulmonic, my for mitral, and assets for aortic, TPMA. Now, if you prefer something slightly more anatomical, you can use try pulling my aorta. Oh, and another quick memory trick. If you ever confuse whether the tricuspid or bicuspid comes first, just remember the golden rule of shopping. First you try before you buy. Tricuspid is always first. Now, let's visualize the physical reality of that journey.
We're looking at the cardiac cycle in action right here, specifically during a phase called systole. Notice the dynamic coordination going on. This is the exact moment the powerful lower ventricles contract to vigorously push blood up and out. And while those thick ventricles are squeezing blood out through the pulmonic and aortic valves, the upper atria are actually relaxed, taking a breather and filling up with the next batch of blood. This beautiful, coordinated dance is exactly what creates your blood pressure and your pulse. And here's a cool fact. During this ventricular contraction, the tricuspid and mitral valves snap shut to prevent blood from flowing backward into the atria. That physical snapping shut of the valves, that is literally the lub sound you hear when you listen through a stethoscope.
But hey, what happens when those valves don't close perfectly? Well, that brings us to heart murmurs. If a valve is damaged, stiff, or floppy, it creates this audible vibration that we call a murmur. These are super commonly tested on exams and seen in clinics, and honestly, they can be incredibly confusing to differentiate. But again, we're going to use focused mnemonics to decode them instantly. If you hear a murmur during systole, which is when the heart is actively contracting, just remember MR-PAS. That stands for mitral regurgitation and pulmonic or aortic stenosis. Let that sink in for a sec. MR-PAS. Now, if you hear the murmur during diastole, when the heart is relaxing and filling, remember ARMS. That stands for aortic regurgitation and mitral stenosis. Honestly, with just those two simple acronyms, MR-PAS and ARMS, you've got an immediate foolproof mental sorting system for clinical diagnosis.
To really understand the actual physics of those murmurs, let's take a look at a condition called aortic regurgitation. Normally, blood flow through healthy vessels is laminar, meaning it moves in these really smooth, silent parallel layers. But in regurgitation, the aortic valve fails to close all the way during diastole. So instead of a nice, smooth, one-way exit, blood actually leaks backward from the high-pressure aorta right back down into the left ventricle. This creates chaotic, turbulent backflow. Think of it like a peaceful river suddenly crashing into jagged rapids. That turbulence literally vibrates the tissues of the heart, and that radiates outward as that audible murmur we just talked about. Clinically speaking, this means the left ventricle is getting hit with volume overload. It's forcing it to work harder and stretch out over time, which can ultimately lead to heart failure. Seeing the visual mechanics makes the clinical symptoms make total sense, right? All right, let's lock this all in with an active recall test right now. Remember that crazy 70% forgetting curve we talked about earlier? The only way to shatter it is to force your brain to retrieve the information without peeking at the answers. So visualize that map we just built. If your red blood cell has just returned from the lungs, so it's oxygenated bright red, and it's currently sitting in a left atrium, what is the exact name of the valve it is about to pass through next? Think about your mnemonic: toilet, paper, my assets. You're on the left side, so you're past the lungs. If you said the mitral valve or the bicuspid valve, you absolutely nailed it. You now have a complete, structured visual model of the heart that you can mentally run through in under 3 minutes flat. So I'll leave you with this final provocative question. Now that you've seen how effectively you can master the cardiovascular system by just stripping away the noise and focusing on structured visual mnemonics, which massive, intimidating topic are you going to conquer using this exact same speedrun technique next?